Hello everyone. Myself Adarsh Deshmukh from Lokmanya Tilak College of Engineering, pursuing my Bachelor of Engineering from Computer Science. Today I will give a brief overview of my IoT internship provided by Emertxe. So starting with content, first I learned C programming fundamentals, then embedded system types, then Internet of Things IoT, then project requirement, then home automation project, then conclusion. First of all, we have C programming fundamentals. In C programming fundamentals, we have data types such as char, int, float, double. Then we have conditional constructors such as single iteration, multi iteration, continue and break. In single iteration, we have if else switch case. Then multi iteration, we have for, while, do while. Then we have operations such as arithmetic operators, bitwise operator, logical operators, relational operators, assignment operators, ternary operators. In ternary operator, we have condition, question mark, expression 1, expression 2. Then we have arrays. What is an array? An array is a collection of data of same data type. Then pointers, pointer pitfalls, segmentation fault, wide pointer. Then we have pass by reference and pass by value, function and recursion, strings, strings library functions, first length strlen, then compare strcmp, then copy char strcpy, then check string strstr, then check character strchr. Then we have storage classes that are auto, register, static local, static global, extern, memory segment, text segments, data segment, stack segment, and heap. Then preprocessor, header files, macro, then structures, then introduction to C++ and OOPS. First of all, we have embedded system. So what is embedded system? Any combination of hardware and software which is intended to do a specific task is called as embedded system. For example, car, TV, refrigerator. Based on performance and functional requirements, embedded systems are divided into four types as follows. First, standalone, second, real-time, third, network, fourth, mobile. First, real-time embedded system. So what is real-time embedded system? It is a strictly time specific, which means these embedded systems are provide output in a particular defined time interval. Further, this real-time embedded system is divided into two types. First, soft real-time embedded system. Second, hard real-time embedded system. So, in soft real-time embedded system, the time or deadline is not strictly followed. If the system didn't give result in the defined time, still result or output is accepted. And in hard real-time embedded system, the time or deadline of task is strictly followed. Example: traffic control system, military uses in defense sector, medical uses in health sector. Then secondly, we have network embedded system. Network embedded system are connected to a network which may be wired or wireless to provide output to the attached device. They communicate with embedded web servers through network. Examples: home security system, ATM machines, card swipe machine. Then we have standalone system, standalone embedded system. Standalone embedded system are independent system which can work by themselves. They don't depend on a host system. It takes input in digital or analog from and provides the output. Example: MP3 players, microwave ovens, calculator. Then we have mobile embedded system. Mobile embedded systems are small and easy to use and require less resources. They are most preferred embedded system in portability point of view. Mobile embedded systems are also best. Examples: MP3 player, mobile phone, digital camera. Then we have memory. Memory is are of three types. First, random accessories memory. Second, read-only memory. Third, hybrid memory. First, random access memory. It is volatile and requires power supply to retain data. It can be written over multiple times. Basically, it has two types: SRAM, DRAM. Then we have read-only memory. It is non-volatile. Data is not erased or power shut down. It cannot be changed once written. Types of ROM: OTP, one-time programmable. Then EEPROM, UV-ROM. Then mask ROM. Then we have hybrid memory. It is a type of non-volatile but can be changed or overwritten for a particular number of times. types of hybrid memory. EEPROM, the second is flash, that is NOR and NAND. NOR means byte accessible XIP and NAND stands for block accessible. Then for Internet of Things, that is IoT. Now what is IoT? IoT is the network of physical objects that contain embedded technology to communicate and interact with their internal state or external environment. IoT makes one's dumb devices smarter by giving them the ability to send data over the internet, allowing the device to communicate with people and other IoT enabling things. Here you can see a brief diagram to know more about Internet of Things. Then we have IoT architecture. Basically, IoT architecture divided into four types. First of all, we have sensing layer, then network layer, then data processing layer, then application layer. In sensing layer, physical objects such as sensor and actuator gathers the data. In network layer, internet gateway and internet technologies transmit the data. Then third, data processing layer. In this unit, processing unit process the information by such as by use by data analytics. Then fourth, we have application layer. Here, smart application and management are performed by using smart application. After that, we have our project requirement. Basically, we have three project requirement. First, control of garden lights. Second, temperature system control. Third, water tank control. So first, in garden lights, switch on and off the garden lights on the basis of sunlight intensity. In temperature system control, switch heater and cooler on and off remotely. Switch heater off automatically if temperature in the room exceeds 35 degrees Celsius. Third, water tank control. Switch inlet and outlet valve on and off remotely. Switch inlet valve off automatically if the tank fills up. Switch inlet valve on automatically if the volume of the tank drops below 2000 liter. All the simulation are done by using Arduino and Picsimlab. Here you can see our basic idea of our project in which we are using Blynk IoT, which is connected to Blynk Cloud, which is further connected to our Picsimlab, and then here we are using this our home automation project. Then we have Arduino requirements. First we have LED, second temperature system, third LDR, fourth serial tank, that is serial communication, fourth Ethernet shield, fifth Blynk IoT app, sixth Blynk IoT app. Then analog to digital converter, that is ADC. There are five types of ADC. First, flash ADC, pipeline, SAR, dual scope, sigma delta. Here you can see how an analog to digital ADC converter or ADC works. Then light dependent resistor. The resistor of LDR decreases with increase in incident light intensity. This is called as photoconductivity. A photoresistor can be applied in light sensitive detector circuits and light activated and dark activated switching circuits. So here you are example of LDR, that how it works. Then Ethernet shield. The Arduino Ethernet shield allows an Arduino board to connect to the Ethernet using the Ethernet library and to read and write an SD card using the SD library. This shield is fully compatible with the formal version but relies on the newer W5500 chip. To use the shield, mount it on the top end of an Arduino board. Example Uno. Here you can see this is our Ethernet shield. Then Blynk IoT app. Blynk is a full suite of software required to prototype, delay and remotely manage connected electronic device at any scale, from personal IoT project to million of commercial connected products. So the function that are use are first Blynk write, second param dot as int, third param dot as float, fourth param dot as double, fifth param dot str, sixth virtual write with pin values, seventh timer dot set interval, that is time comma function. Then we have project solution. First, garden lights, that is input LDR sensor process, read the LDR sensor value. Based on the reading from LDR, vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. Then output, that is garden light. Then LED. LED, it is the simplest device used in most of the embedded application as feedback. Then PWMs, it is used to vary the active time versus inactive time in a fixed time period. It is mostly used to control the average voltage of the load connected. Then function use. First pin mode, second digital write, third digital read, fourth delay, fifth analog write. Then we have temperature control system. The temperature control system consists of heating register, an LM35 temperature sensor, and a cooler. Read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature on the system by turning on off the heater and cooler throughout the Blynk IoT app. First we have input, that is temperature sensor. Second process, read temperature from temperature sensor LM35. Then output, display temperature on gauge widget, display temperature on CLCD. So here we have a diagram that how our temperature system works. Here you can see temperature system is connected to Arduino Uno and our Arduino Uno is connected to our Blynk IoT app. Okay, now for further we have cooler control system. First inputs button widget, that is cooler button on Blynk IoT app. Then process, detect the change in logic level. Then output, if the button widget is at logic high, turn on the cooler. If the button widget is at logic low, turn off the cooler. Then we have a heater control system. Inputs, button widget, heater button on Blynk IoT app. Then process, detect the change in the logic level. Then output, if the button widget is at logic high, turn on the heater. If the button widget is at logic low, turn off the cooler. Then we have threshold temperature control. Inputs, temperature sensor, then process, read and compare the temperature with 35 degrees, then output. If the temperature is more than 35 degrees, turn off the heater and send notification to Blynk IoT app and display the same on CLCD. Then we have CLCD, most commonly used display ASCII characters. Some customization in symbols possible. Then communication mode, it has two types, 8-bit mode, 4-bit mode. Then we have function use. First liquid crystal 12C, used for addresses column rows, then set cursor column rows, then print string, then LCD dot init, then LCD dot backlight, then LCD dot home, then CD dot clear. Then we have water tank inlet and outlet valve control, that is read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Display the volume of the water in the tank on the CLCD. So here again we have a diagram that shows us how water tank is connected to Arduino and Arduino Uno connected to Blynk IoT app, and how does this all will work. Then display the volume of water in the tank. First inputs, that is serial tank. Then process, read the volume of the water in the tank by sending commands through serial communication. Then output, display the volume of the water on gauge widget. Display the volume of the water on CLCD. Then we have inlet valve control, that is input button widget, inlet valve button on Blynk IoT app. Process, detect the change in the logic level. Output, if the button widget is at logic high, turn on the inlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the inlet valve by sending the serial commands through serial communication. Then we have outlet valve, input button widget, outlet valve button on Blynk IoT app. Then process, detect the change in the logic level. Output, if the button widget is at logic high, turn on the outlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the outlet valve by sending command through serial communication. Then control the volume of water in the tank. Input serial tank. Process, read the volume of the water in the tank by sending commands through serial communication. Then output, if the volume of the water in the tank is less than 2000 liters, turn on the inlet valve and send notification to the Blynk mobile app and display the same on the CLCD. Then the function use serial.begin for speed, then serial.train str, then serial.train value, serial.write buffer length, then serial.read. So here's the conclusion. Using the Pixin simulator and Blynk IoT application, we have simulated home automation where LED system, serial tank resemble lights, heater, cooler and water in the same time. Okay, now we will see the code of our project, and after that we will demo our project. We will see a demo of our project. Okay, so here we have our code for our project which we write using C language in Arduino Uno. So here you can see, here we use the Blynk template, Blynk authentication token, Blynk light function and other. We have here LDR functions, then main and serial tank, then temperature, and then again temperature function and serial tank.cpp. All these are combined in our home automation main file. Okay, so now we will use this uh, project to run our we will use this code to run our project. Okay, I will at the end I would like to conclude that these are the things that I work on this project during the whole internship, and I would like to thank Jayashree ma'am for clearing our doubt time to time, that we post in our that we post in discussion form, and also clearing our concept, and thank you for all the things that you provide us. So And also thank to Emertxe for providing us a great opportunity. So thank you, all of all of you.